So this work I have already done, so I just let you know what is the difference between 2D and 3D. So only the geometry difference is there. So this is a curve plate. So initially I have defined all the parameters like the 2D geometry only. Then we'll go to the component section. So here components of 3D type. So under this geometry, I have draw the geometry in this console only. So the thickness of this geometry I have defined in the parameter, which is 0.01 meter, right? So we'll go to this is our geometry. Then we'll go to the material, same as 2D, that blank material I have added, and the properties that automatically I have taken it here, right? Then we'll go to the physics, heat transfer in solid. So under the solid section, everything is same, nothing different. That thermal conductivity, density, specific heat capacity, all are from material. Initial values I have mentioned here 315 Kelvin, which is user defined T. Here it comes all domains, right? Then thermal insulation is not needed, it is overridden per mole temperature. So here the key is that mole temperature is for all boundaries. If you will see, this all boundary will be here. All boundaries will be there for the mole temperature. This is also user defined. In 2D, there was just one boundary was there, like, but here this whole domain will be there, like domain, not boundary of this whole domain, because it's 3D part. If I will show now, see, this is this one, this part is this one is this bottom side, this is top side, like this. Okay, so this is the mole temperature. Heat source also the same that we have mentioned in the 2D part, minus HR into d alpha by dt. Now let us come to the domain ODEs and DAs. What is that? Okay. So yeah, here actually I have uh, this is the empirical model, Kamalansauros fourth form of model. That time I think I have told for the Kamalansauros autocatalytic model. So the equation is different here. Nothing's this equation is depend on which model we are going to use. So this time for this part I have used this model. This is not like for 2D only we have to use that model, 3D only we have to that model. Depends upon our resin properties and everything. We'll try which model is best. So there are a number of empirical models. That file is already shared with you. Initial values 0, alpha 0, do alternative 0, or you can like take like close to 0 value, like my take for -8 or something like that. Then this is the meshing. Okay, so this meshing is there. This component 2 is just like initially I draw 2D geometry in the component 2, and then I have imported the geometry into 3D component. There is nothing different. This is for the geometry purpose only, because here I have drawn the geometry here itself. No, that's why it is showing like that. Okay, so like this I have drawn the geometry in 2D, and then that I have imported into 3D component part, and then I extruded it. Nothing different. But if you are making geometry in other software, then you just import it here and do the meshing. You don't have to add any other component. Okay, this is just for the geometry purpose. I have added this another component. Yeah, that's it. So let us come to the study part. Actually, here I added first parametric sweep because I changed the thickness of this geometry, like from 10 mm to 30 mm. That's why I used a tool parametric sweep. Later on, you will get to know about this, like once you will comfortable with this part only. So I will just try the simulation for 20 seconds so that it will run fast. But again, my all solutions will change. But anyway, let it be, no problem. I will not save it file. Okay, so we'll run it. Let us see what happens. As the geometry is may it will take some time. Computational time will be more. But the Curie time is based upon the raising properties as well as the complexity of the geometry. Yeah, so it has simulated. So same we'll have control plots in 3D temperature. This is for the degree of cure. So this is for degree of cure here. So for 200, say, oh, it has taken previous value only. Sorry, this is a parametric solution, that previous solution it has taken, but let us see the solution 1 and let us plot now. See, now this is for like a geometry, that 10 mm geometry, and if you'll see the degree of cure is -3 because the time is only 20 seconds. Na? Once we'll increase the time, definitely it will, the simulation will, the degree of cure will reach to 1. So this is 1D plot I have drawn. Okay, so like this, actually this work is like for another purpose, that there are so many results are there, but just for understanding 3D part, you can, there only this much is there. Okay.